Circles, rays, and lines. We're going to look at these using complex numbers. So starting off with circles, if you remember, a basic equation for a circle was x squared plus y squared equals r squared, and that has a center at the origin and a radius of r. Okay, so the same thing you can write much simpler using complex numbers. You can just say the magnitude, or the absolute value, of z of your complex number equals the radius. Okay, so this, remember, magnitude, absolute value mean distance from 0, or in this case 0, 0, the origin. So this is telling us this is the set of all points that have a distance r from the origin. So all the points that are distance r, so all these points in the circle. Okay. So the other equation is also just a set of points, all the set of points x and y, so that x squared plus y squared equals r squared. Just this sort of looks like Pythagoras a little bit, if you remember. So this is x and y. So x squared plus y squared equals r squared is Pythagoras. So it's all the triangles that have a hypotenuse of radius r. Anyway, now we can shift these circles. So in Cartesian, we might have had something like x plus 2 squared plus y take 3 squared equals 16, for example. This one, the plus 2, remember it's the opposite. If it's a plus in the x, we're actually shifting left 2. And if it's a minus in the y, we're actually shifting up 3. And the radius equals 4, because this is 4 squared. Okay, so this circle has a center 1, 2, negative 2, 1, 2, 3, up 3, and a radius of 4, which is probably going to be something like that. Okay, so here's the distance of 4. So in complex numbers, the way we do that is we're going to shift left 2, okay, so that's going to be a minus 2, so we're going to have z. So, sorry, left 2 is also a plus 2, okay, because now we're going to have, this is the real, and this is the imaginary. Okay, so left 2 on the real, again the opposite of what you would think. But to go up 3, because this is the imaginary, you put an I there. And that equals 4. Okay, that's all you do to sketch the same, to draw the equation of the same circle. So, for example, if we had something like z minus 1 plus 2i equals 5, if we want to sketch that. So this is going to be right 1, down 2, radius 5. So, to the right 1, so we're over 1, down 1, 2. Okay, so here's our center, 1 minus 2, and a radius of 5. So really, 1, 2, 3, it's going to come through this point. 1, 2, 3, 4, 5. It's going to go through that point. 5 up. 1, okay, 1, 2, this minus 1, minus 2, minus 3, minus 4. So it's going to go left 5, 1, 2, 3, 4, 5, etc. Not a very good scale here. This is looking like an ellipse. But hopefully, oh, that's a terrible circle. Okay, worst circle I've ever drawn. Radius 5. Alright. Yeah, and that was, of course, complex. Okay, lines. Let's look at lines. We're actually only going to be looking at, as far as lines go, we're only going to be looking at vertical lines. Okay, let's say this crosses at 1, 2, 3. Okay, this line 1, 2, 3. So normally this line in Cartesian would be just x. So this is my x, this is my y. It's just x equals 3. In complex, it's going to be, well, this is the x is the real, y is the imaginary, so it is just the real of z equals 3. Okay, the real part equals 3. That's all. Very simple. And if we had another line of y, let's say this one went through 0, 2. Okay, so this green line, so this was the red line. Now we're going to do the green line. So Cartesian, that's y equals 2. So have a guess. Guess. What do you think it is? Imaginary of z equals 2. Very good. Alright, you can also shift these lines, just like we shifted a circle. Okay, so if I have something like, let's say, sketch, what do we have to, example 2, sketch, real of z plus 2 minus 3i equals 2. No, let's not do 2, let's do 3. Alright. Okay. This would normally be a line that would go through 1, 2, 3. Okay, normally it's going to be a line that goes through 3. This would be the original line. This would be real of z equals 3. But what we're doing is shifting this line. Okay, this is to the left 2, and the minus 3 is up 3. Okay, so we're going to take this line, shift it left 2, so it's going to go through this 1, and then we shift it up 3. Of course, if you're shifting, it's a vertical line and you're shifting it up 3, it has absolutely no effect on the line whatsoever. So this is the line, real z plus 2 minus 3i equals 3. And you would do something similar for imaginary. So, example 3, sketch, and I would encourage you to try this at home. Okay, and then check your answer. Pause. See if you can figure out what this should look like. Okay, pause, pause, pause. Okay, you're back. Let's sketch it. Okay, we've got a real and an imaginary. So, so z is minus 1. Normally it would go through minus 1, like so. But of course we're shifting it to the left 1 and down 2. So which of those has no effect? Come on, which one? That one, yes, no effect. So all we do is shift it down 2, 1, 2 to minus 3. So we go down 2, and this is our line, real z plus 1 plus 2i equals minus 1. Okay, ray. Now, rays. Let's do this. Rays. So a ray is a line, but it has a starting point. It continues only in one direction. Okay, so this one we don't really have equations in Cartesian unless you, say, put a condition that x has to be bigger than something or x has to be less than something. Okay, but if I have something like this, the argument of z equals pi over 3. So what does this look like? Okay, argument of z is pi over 3, which is 60 degrees. Okay, so obviously this point here, from the origin, that point has an argument of 60 degrees. And so does this point, so does this point, so does this point, so does this point, and so on. All these points have an argument of pi over 3, okay, because this angle here is pi over 3. Okay, so that is a ray. That's what a ray looks like. And you can also shift a ray. So if I had arg z equals, arg z plus 1 minus 2I equals pi over 3. Of course, I'm going to shift this left 1 up 2. So I take this whole thing and I shift it left 1 up 1, 2. Okay, so this is the new starting point is here at 1, so negative 1 and 2. Alright, so this is, of course, my imaginary real. Alright, and then make it just a horizontal because we've got to measure our angle with the horizontal, and we draw our ray going up at that pi over 3 angle. Okay, so you could draw, for any angle, you could draw this. So have a go with arg z minus 2 plus I equals negative 2 pi over 3. Okay, have a go, pause, sketch that, pause, 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 go back, here we go, negative 2, so we're plus 2 in the x direction, and we're minus 1 in the y direction. So minus 1, so we're down, minus 1, 2. So we're right here, and negative 2 pi over 3. Okay, so here's our horizontal, so we're going to make this angle from the x, so it's going to come down this way, negative 2 pi over 3. So negative is going down, okay, which is 120 degrees. So basically this is our line. Okay, finished.